right? There are multiple people who are involved, multiple levels of people who are involved in the data science team process. So they need to have the business understanding, right? It is very important to define the business objectives. Otherwise, there is no point. It's not like listening to the business what they want to say, right? But actually help the business understand what is possible with the data that is available in the company, right? So he needs to have understanding and also should be able to apply the statistics and the mathematics and the formulas that is involved to achieve that objective, right? So he needs to have the business idea at the same time what it takes to achieve that business goal, right? So that should be defined in the first step. It's similar to any other business process, any other project that happens in a company, right? You define the objective, but the objective should be based on the mathematical understanding and the data that is available and what is possible that will improve the business, right? So that's like the top layer that sits there. The next person is the next step basically in the process is getting the data, right? The data sits at different places. People started realizing that in companies they have billions and billions of rows that they have been collecting, but are not using any of them, right? Like the web logs and how your website is being tracking, and all that information is being saved somewhere, but they were not analyzing it, right? So it's important to find that data where it's sitting. Different teams using different types of data, products to save their data. Some of them use Excel, some of them use flat files, right? So we need to find that data sources. So that's the second step. The third step is where you actually have the data, and then you find the right algorithms that can analyze that data, read through that data, work through it, and then come up with a model that you can use to predict future.
Is this what we define as data wrangling?
So the question is that what you define as data wrangling? So data wrangling is mostly in the data discovery and acquisition phase. That's where you prepare the data for the model. So you get it into standard format so that it will be easier for the next step where you use that data to make some decisions.
So what do you mean this data wrangling? Because people are using this terminology quite often. So what do you mean this?
So it changes from each case to case. What you want to achieve, based on that, you need to get the data, right? So, and it depends on where you're getting the data from and what format it is available, right? If you have text data, it's hard to make any sense out of your PDF files and text files. What you want to do is like identify the key elements in that text. Like there would be, president news, new election, right? That keywords, kind of picking those keywords, right? And that forms your data. So working out how your data source should be, that's kind of your data wrangling, right? And also there is sometimes sales data, and then you have different if I call it in the BI terminology, like you have fact tables and the dimension tables, right? But unless you define the data, like you need to work out the model first, and then at the end, what the data that you get is what you get after your data wrangling. So it depends on case to case what kind of source you have, right? So that's the data wrangling bit that fits in the data acquisition and discovery phase.
What's the difference between data wrangling and ETL?
Good question, actually. So they are similar. They are not same. They are similar, but it's a different terminology, I would say. But it also depends.
Is it just about terminology or something else?
It's terminology, but there are some extra bits that you don't do it in ETL, which is that's what, like playing with your data, getting the data into the right formats, right? So that happens even before your ETL. Right? ETL is mostly like you extract the data and then make the transformations and then pull it into your data warehouse or other systems. But data wrangling is where you start even before you get to that stage where you're extracting the data.
streamline that or something?
It could be anything. That's what
To
I'm saying.
make this more
The
that
source.
you have to have clean data to be able to do model and text instance, which means your ETL process should be, your transformation should have been one.
Yes and no, not exactly, but means yeah.
Yes.
Even before ETL, there is a bit of data. It can fit in any stage actually. Right. So we'll have more discussion after this session, right? About data wrangling. I'll get to that. But the modeling bit is where you actually have your data ready, and then once you have the data ready, you train your model with that data, and that model, the trained model, is going to be used for your predictions later on when you have the data. Deployment is of course when once you have the model ready, how do you operationalize it, and at the end it's important to compare it against your objectives, whether you have met it or not, or if something has changed in between, right? It's similar to any other project that you have. So that's the last bit where you do some testing, retraining, because the data changes over time, the trends change over time. So you need to continuously keep retraining your model to fit your business. So there are two different roles that we can talk about. One is the machine learning engineering role, and the other one is the data engineer role. So machine learning engineer role is mostly the developer side of things in terms of machine learning, right? So they need to have a very detailed understanding and close to expert level of expertise in Python and R programming. Python or R programming. There are other programs, also programming languages also, but these are the most prominent ones that are being used currently in the data science world. They should be able to. There are many algorithms that are available already, so most of them can be used as is. There are very few cases where people actually go and write their own algorithms. So we can choose the models that are already existing. To start with, they are very good. They need to have decent understanding about statistics. The advanced steps would be, having an idea about neural networks, which is more about deep learning, depending on what data they are getting and what is the use case. But they are more advanced steps. In the data engineer role, which has been kind of existed forever, this is where we talk about the DBA and BI. This is where we step into data science world. From this step, we can actually move towards the the machine learning engineer role, right? But we are mostly in the data engineer space if we are coming from a DBA or BI background, right? So this is more to do with playing with the data rather than working on the model or the predictive side of things. And as I've said, most of the prominent languages that are used for machine learning are R and Python. So it is good to have knowledge about one of these languages. So learning a language is mostly, trying to understand how it works, rather than what is the syntax and what we don't worry about that much. It's more about what the language can do and the science behind it, rather than the actual syntax. So R, basically, this is gone out of a research project at University of Auckland actually, and then it is mostly used for data management. They have packages. There are about 10,000 packages in R now, right? And they can be used for. There are different packages for data manipulations, calculations. Of course, ggplot, which is most famous for, most popular for how you plot graphs. So we'll see how we can plot graphs by using ggplot later on. And with SQL Server, the best thing is if you are already using R or Python, you can actually run the same code inside your SQL Server. So the benefit of running R or Python in SQL Server is, SQL Server is basically a database engine, right? And it understands data. It can work with data the best way rather than any packages in R. Right? There are some functionalities which are better in R packages, but when it comes to working with huge amounts of data, parallelism and joins and whatnot, what all features that are available to work with data is best in SQL Server. right? So you do all your data bit in SQL Server, and once your data is ready, that's when you put in your R code inside SQL Server, like in a procedure, or do all your data bit, and at the end append the R code where you actually do your model, training your model and doing the predictions, right? So let's see the usage of R in SQL Server. So to run external code, so TSQL is native to SQL Server, but when it comes to R and Python, they are not native to SQL Server. So Management Studio doesn't understand R or Python. Management Studio understands TSQL syntax, right? So to enable it, what they have done is they have added a configuration parameter that you can turn on and off, and you can pass the script as a parameter and then tell what language it is. And based on the language that you are specifying, it will choose the engine to run that code. So behind the scenes, when you try to run R code inside SQL Server, you specify that it's R code and then provide the R code as a parameter, and then it picks the R engine to run the R code. Right? Even though you're running it through SQL Server, it's actually R engine behind the scenes. Similarly with Python as well. So the configuration parameter is external scripts enabled, right? And the best thing with this is, in 2016 they introduced R, in 2017 it's Python, and then there can be more languages that they can fit into, to run with SQL Server, right? So it's more flexible in terms of which code you want to run, and future changes for the product team as well. So all you need to do is enable this configuration parameter. I'll switch to the database. I've got a table which has few lines of code. For the example purposes, I've got a key value pair, right? Based on the key value, I'll predict the return value, right? So this is my input data. So it will read through this and work out a formula, like based on what number we pass, what should be the output. It will work out a formula based on the linear model that I pass in, right? So we'll not worry about the mathematics behind it, but it's more about when I pass in a key value, it will return a value but it is based on the analysis on this data, right? So it's close enough. When I pass 14, it should be somewhere between 13 and 15, right? So that's what I should get. And the values that I'm going to pass as an example for input is those 1, 2, 3, 5, 7, 11, and 13. So for those values, what should be the return value that will be predicted, right? And with predictions, it's always like probability. If you remember probability in colleges, it's not like when you roll a dice, right? So you will get the number 6. 1 in 6 chances that you get that number 6, right? That doesn't mean that when you play 6 times you get the 6 ones at least, right? So it's not 100% accurate. It will never be, because things change. There are so many things that are affecting the outcome. So if you consider everything and the time factor, and there is always that small bit of randomness that can come into your predictions, right? So in this, what I call is SP execute external script. So that is the procedure which we call for running the script other than DSQL inside SQL Server. And here, this is where I specify the language. So I can say R, and if I pass in a Python script, I can just say Python, right? And then this is the script that I'm going to run. So this is basically an R code. What it is doing is Rx lin model is a function. Lin mod is a function for linear models, linear regression. So I just pass the formula telling that predict analyze the return value based on the key value and base it on the data that I'm passing in. Lin model data is the input, and in the input data I specify the query. So this is the lin model data that I just ran, right? The select star from that. So that is the query that I'm passing in. So it's analyzing the data that I have shown earlier, and then it's training the model based on that data, right? And I just serialize it serialize it with a connection, but when I pass in null, it's just a raw vector, and then I'm just outputting that model, but it's a bare binary, string, which doesn't make any sense, but internally it has the model that is saved. And once we have that model, we can actually use that model, right, and pass in the predicted values, which is the data that I've just inserted here, right? So pass in that values and predict based on the current model for the new data set that I'm passing, right? And I'll just output that into a table and then return it so that I can see what's predicted, right? So you'll have all this code, and these functions are a lot of documentation available on the functions. So we'll not go into detail about how those functions work. We don't have to actually. It's more like they are available. So I'll run all of that. This is the first time I'm running this morning, so it actually loads the R engine. So it takes some time for the first time, but from second time onwards, it depends on how much data you have that the model uses for training. Right? It's only very little data. I had like 20 rows. So the first string that I've got is the where model that was trained. Doesn't make any sense with that string, but it has the logic behind how the values are predicted. So the values that I passed in, you can see that these values that it has predicted is close to the one that we had in the table, right? So I mean, you understand the concept. It's basically how we can run that R code inside SQL Server, but all of this we would not be able to do inside SQL Server before SQL Server 2016, right? So we are just bringing the power of R into SQL Server and getting that data.
What is the first value?
This one is the train model that I have here. So in the model, I am actually saving so model bin, which is coming from here, right? So that is the train model. I have trained the model with the values that I have, right? And that is the train model. We will see the graphical representation of this in Azure ML Studio. That's when you will be able to picturize what I am trying to explain, right? But you will not be able to see it. It's basically the algorithm which has got the trained data, and then you can use that model to, whenever you pass in a new value, it will predict because it has got the coefficients and weightage that it is calculated beforehand based on the data that you passed. I'm just displaying its output as an output.
So 2016 already has R in it.
Yes. So in SQL Server 2016, you can run R code, not Python. From 2017, you can run R and Python. So the syntax doesn't change anyway. It's basically whatever code that you write in Python, you can just place it here and say that's the Python language. Right? And so that's how we can actually use. For me, I have never seen R code till January this year. Because I have submitted this session for SQL bits, I had to prepare, and then that's when I started learning this. Right? And this is a session I gave at SQL bits in London. So it's not hard, but the hard bit is basically learning R, right? So the actual modeling and those bits. But to step towards it, the first step, this is the first step that I have taken. So this is where you can start, right? So R Studio. Sorry.
Do we use more R Studio or use R Studio in Studio?
Okay. So what is the preferable tool to run or development environment? R Studio is designed for R. Management Studio is designed for T-SQL, right? And they have separated out Management Studio out of SQL Server. Now, when you install SQL Server, it doesn't install Management Studio. You have to separately install it. That's because there is a lot of functions designed to help DBAs. right? You have got the object explorer where you actually do maintenance tasks and all those things. But also at the same time you can write queries. But none of the developers, actual developers, like SQL developers, they actually use Visual Studio, not Management Studio to write SQL code, right? So these are tools that will enable you to run, but Management Studio is not designed to run R code, right? It's the functionality that they added to T-SQL that can help you run R inside SQL Server, within SQL Server, but it's not good for developing R code because when you see the syntax, it's actually a variable, a parameter. So you don't know what you're typing exactly. You can't test it at all. Like, it's really hard to test R code. So for development purposes, R Studio is good, right? All right. So I've covered most of what is on this slide in that answering that question. So let's jump to R Studio. Anyone used R Studio before? Quite a few. That's good. Alright, so quickly about the tool. So you've got your development section here where you write your R code, right? And then at the bottom is your console where you actually whatever you run in the query window, right? It's not query window, it's a script window. And whatever you select, you can select bits and run, like similar to your Management Studio or similar to your PowerShell environment. PowerShell is integrated ISE. And then where you have the console at the bottom, and then you can write scripts on the top, and then you can just select the bit that you want to run and execute it. On the right side, on the top, you'll see the environment, history, and connections. So whatever connections you make, it's listed down here. The history, whatever commands you have run, and then the environment is where you actually create the variables and any bit that you create, you'll be able to see it here. And the right side bottom is where you will see files, packages, and all those things. The packages that you have loaded, the packages that are available by default. All those things are at the right bottom part. So when you plot a graph by using ggplot, we'll see in a minute, that will be plotted here at the bottom right column. Right? So that's basically the R Studio. And also it has the grid result set, but that comes up as a tab beside your script window. So I'll just load load few packages. So RODBC has packages to as the functions to load, make ODBC connections. Modeler has the algorithms that I'm going to use, and ggplot2 is the one that I'll be using for graphics, right? So I've got an ODBC connection called SQL 16, which connects to my SQL Server, which I had previously, right? So I make an object for that connection, right? And using that connection, if you're familiar with development before, with C# or any other language, it looks similar, right? So it's a function which takes parameters. So SQL query, by using that connection, run that query and then get the output. I'm saving it into data, that is an object, right? And when I run that, if I just select data and run, it will display the result here at the bottom. This is not that readable, right? So I can say view data. View is again another function, and when you run that, it will actually display the data in the grid format, right? This has nothing to do with R, it's just few tips around R. There's nothing to do with data science, right? Other bit is like what you do with PowerShell, you pipe and then pass the output of the first command to your second command, right? So you can do the similar piping thing with that symbol, percentile greater than a percentile. So when you run that, actually I'm passing data to the function on the right, which is view, which is similar to running view data, right? View with that parameter, right? So by using that, what I'm going to use is do is LM. LM is a function which again is trains a linear model, right? And I predict rate. So if you see that data set, I've got three different parameters based on which I have some rate, right? So for ping file length 1.9 width, the rate is 0.4, right? These random variables that are affecting the output, right? So what I do is I predict the rate based on the color, length, and width. Even though they are in text, like ping and these things are text, it will actually enumerate it, like it will have some values for it, and then calculate based on it, right? Inside R Studio has that power, but if you go to Azure ML Studio, you have to manually convert those values to numbers, right? So that's the only catch there. But it converts that and predicts the rate based on that. So when I do that, when I train the model and then put the summary out, at the bottom you see the coefficients. So coefficients is where, if you, in normal terms, what I would say is weightage of each variable that is input, right? That is input for that rate prediction, right? So the weightage of pink color is minus 0.49. Teal is that, and then length is 0.0415, right? So based on the input delta that you're passing in, you just multiplies with this coefficient and generates out, gets out, right? So that's how your rate is predicted, right? So this is just simple math behind it. This is another way of viewing it. Broom is another package which has got some functions that will help you read it in a more readable format, display output in a more readable format. So this was not that helpful, but here it puts the estimate, right? So that is your estimate. Alright, so I'll do everything in single step. So what I'll do is predict the output based on the data that I have, which is this one, right? Whatever data that I have, I'll pass in this data and predict the outputs, right? I use the same data set to train the model. Now I'll use the same data set to make the predictions. So we'll see how close the outputs are, right? So add predictions by using that model and on that data set which I'm passing through the pipe command, and then once you get the predictions, you just plot that as a graph, as a density graph, right? So that is what the command is doing, right? So when I run that, in the plot section at the bottom you'll see the density graph that will pop up in a few seconds. But while that comes up, see the analysis. See the analysis that has happened here. So let's take that example of the row that I was talking about, pink with 5 and 1.9, the fourth row, right? The actual rate was 0.4, right? So when I pass in pink is 1, blue and teal I am not passing in, length is 5 and width is 1.9. And we had the coefficient before, right? So that's like the intercept, that's always there. And then I've got that weightage for pink, that for teal, which is 0. So I'm multiplying with that with 0. And then 5 with the weightage for that, which is 0.04159. And then 0.454 for that 1.9 width, which is a width. And when you calculate that value, just got that. That's 0.42, which is close to 0.4 that we had, right? So it's close, it's not 100% accurate, but it's close. And it depends on how distributed your data is. In this case, it's actually a normal distribution, right? It's not deviated much. And then, alright, so that's how the linear regression model works. And we have seen how we can. So this is basically some introduction to R Studio, right? So you know where to find what. Enough of code. Let's get to something which we can do without coding. How many DBAs in the room? And out of them, how many don't like coding? Okay, few hands. That's good. Yeah, kind of. Alright, so for us, Azure ML Studio is best. That's the first step that we can step into. It's easier to get start learning about data science when we are using Azure ML Studio. So this is a slide from the link. The reference is here, but you can go to this page and start on different tracks, right? With Azure ML Studio, if you're new to machine learning, it will start from basic. If you already know R and Python, you can start from here. If you're already a data scientist, from here. And if you're new to the product, then just that link. And also it is integrated with R and Python, so you can actually add R and Python code inside your Azure ML Studio. So eventually we can get there. So let's go to. So this is how the interface looks like. This is all hosted on cloud. So whatever model that you're training, the resources that is needed is actually dynamic. Like you don't reserve any resources for this one. As you use, it depends on how much your usage is. I think there is some limitation on free usage, and then you start paying after that, right? For a single account. The hack is you can create new account. Right. But the important thing is, like, once you operationalize it, once you publish the training model, then next time when you want to rerun it, you don't want to create a new account and operationalize it, change the link and change all your applications, right? So it's easier to pay the price. Alright, so what you can do is you can actually create experiments where you pass in the data, whatever we were doing initially in RStudio or in SQL Server. We pass in the data, and then we split the data so that you can use some part of it for training your model, and then some part of it to score your model, like to test it, right? And then you have a model, you have an untrained model which you use with the data that you're passing in, train the model. That's where your actual resources are consumed. And then once your model is trained, you get a trained model that you can use for predictions, right? All this can be hosted as a web service. So all you need to do is a HTTP call by passing your input and get the predicted output.
Is there a rule of thumb on how many percentage of the data that you put for training and test?
So if you are looking at production usage, basically scoring is like testing. So it's always suggested that on a production usage, you actually use all your data for training, right? But for testing purposes, when you split it, 70-30, depending on how much data you have. If you have huge variance, because this splits the data randomly. So if you're getting huge variance, it's suggested that you run the test multiple times, so that your test tells you how close you are to the predicted values. So yeah. So let's start with this one. What we need is a data set, right? It has got some sample data sets that you can use, right? But we'll not use the sample one. What I'll do at the bottom, new, and then I'll get the data from a local file. Predictive samples. Alright, once the data is loaded, what I need is an experiment. Experiment. There are some templates also that you can use, but got the number right. And once you start the experiment, you see, like, it looks similar to your integration services, right? So you can drag and drop objects on there, and then you can set the parameters or change the properties of attributes of each object. So in this, you can see my datasets, and there are sample datasets. So there are a lot of sample datasets that you go and practice with, right? There are different kinds of datasets here. German credit card. I don't want to get that. Alright, so this is my CSV data, right, that I've just got in. And once you get it here, you can actually view the dataset, similar to what we had in RStudio, right? But we are not writing it over here. That goes a bit slow. What we need after that is basically split the data. So it's a transformation, and I get the input from the data set, and I set the data. Say I want to use 70%, let's see, 70% for training, the model. So for that, whatever fraction I specify here is the first output, and second output is the rest of it, right? And then once I have this, I want a model that I can use. So we'll use the linear regression here and a machine learning. And previously, when I've said when I've talked about models, there are a lot of models that are available. So you can see a lot of models here. And later on, I have a slide which will tell you like what models can be used in different cases, right? So you can refer to that, and it's updated online every day. So whatever the new model is added, you can see it there. New algorithm is added, you can see it there. So I'll be using the linear regression. So once I have that, what I need to do is train the model. So train model. What it needs is the model and the data that it needs, right, to train the model. And once I train the model, I need to score it. So I've got a trained model based on that 70% data and the input from here. And train model, it asks based on what columns I need to get trained, right? So we pass in key based on the key. So it just needs the inputs, and whatever rest of the column is there, that is the predicted value, that is the output. And then we score the model, right? So when I run it, it saves and runs it, and this is where it is actually training the model, right? Based on the input data and the model that I have used, it trains the model. Once we have this, we will publish, not publish. We'll set up a web service as a predictive web service, right? So when we do this, it will mix us everything, right? And then what it does is like, it has got a sample data set. You can always go back to the training experiment and then retrain your model, right, by changing the data set. But once you have the experiment, it can take a web input, right, and then use your train model and then score the model and give you a web service output, right? So it's an HTTP call. We'll see just a minute. So we'll run this so that your experiment is saved, and then we'll deploy it. So in this, previously we have written some lines of code. Here we are not even writing a single line of code, right? And we will use some code, but we will not write any code in this example. So we'll deploy it, and when we deploy it, it deploys it as a web service on Azure, and it will give you all the details for connecting to the web service. So it has given you an API key. So it's basically a web API, right? You can make a HTTP post request, and then it will return you the predicted value that is coming out, right? So I've got the API key, but where is my URL and all that information, right? So at the bottom, we can see the request response. So that is what we'll use. And when you click on it, it will take you to a page which has got all the information about your hosted web API, right? It's a bit slow, but let's wait for it. Alright, so it has got all the documentation about how to consume this web service, web API. So your post request is that, right? That is your post request. And then if you scroll down, that should be your sample input, the format of your input, based on the key pair that you need to pass in. And then that is the sample response that you get. So this will help you in passing the input, preparing your input and then passing the output that you get. But not being a developer, we have sample code at the bottom. So we have C#, Python, or R, whatever you're comfortable with. So let's see the R code. Alright. All I need to do I can run, basically it's making the HTTP request using curl, right? And then passing in the body. So in the body, I'll just pass in like a couple of values here, 17 and 18 as the key values, and then it will predict the output for those two values, right? And once I get the output, it actually shows in a grid, or just displays the output. So let's run that. If you see the messages at the bottom, actually it makes the connection to the HTTP. It makes the connection to the web API. Alright, so it's trying to connected, passes, and it has got the output, right? The 17, for 17 it has predicted that, and for 18 it has predicted that, right? But that's not visual appeal. That's where I can use my ggplot, right?
Shine is a good one.
Sorry?
Shine is a good one. Like me. Use it.
No, I haven't. As I've said, like I've started using
More
R.
fancy. More practical.
Yeah. So yeah, with 10,000 packages, there are multiple options and multiplication of some of the packages. Some are good depending on of which organizations and styles. So what I am doing here is basically saving that output. I mean, passing the JSON, getting the results, and saving it into a variable, and then again getting a data frame, and then using ggplot for plotting that. They're close actually. They are actually different. You see, again here, 94736. Alright, so, but you understand the concept, like, we haven't wrote a single line of code. All we did was drag and drop, and then we deployed the web service. Anyways, I'll go back and check later on and then fix that. But it's more important to understand like what we are doing here exactly, right? And once we get that, the R Studio is useful, wonderful, all that. But if you are having a visualization environment like Power BI, the best thing with R is integrated into Power BI, right? Not Python yet, but R is. So
Chrome website.
this one?
Where did you copy that?
Here.
What is that website?
Oh, on the web service, once you deploy, it has the help page here. So that is the request response page. Right. So the help information is on the side. Test it. Alright, I'll not do any new things here. But so in Power BI, I need to just choose an R visual here on the top. So when I select an R visual, it gives you an R script editor at the bottom. Again, this is not great. This looks like just text editor. All I'll do is basically copy paste all the code that I had in RStudio. It will display the exact result set that I got, the exact visual that I've got there. So whatever I was using with ggplot, it plots it on my Power BI dashboard. Right? So just picturize this, like you have a trained model, detecting some anomalies in your production line or something, right? And it has a constant feed coming through your stream analytics, right? And then you make a HTTP call, passing in that value, and you're getting the return predicted value, right? And you can have that live stream going to Power BI. right? Monitoring, but it's actually predicting. It's not something, an input value which doesn't make any sense, but analyzing the data and then having a training model and using that for live monitoring, right? So that is like ultimate usage of machine learning in a real world production scenario. Right? Question?
The train model, can you refine it or does it get
You can
refined
retrain it.
every time?
You can retrain it.
So the input what you're passing in, can that be consumed and retrain that model?
Yes. So when you are training this, when I go to my experiments, so I can retrain this model which I have just created here. So this data input, this input.
So you use
You can change
70% of that to
Yes.
train the model.
Yes, but I can actually change this whenever in real production scenario. What you do is like you can use the latest data set to train your model again,
Sure.
retrain it,
Yep.
and then when you publish it, you can update your. So that's why you will actually see once you publish it, you can actually retrain the model here. That's the training experiment.
Yep.
But here you can change it so that it retrains and uses your model. Right.
I mean, is there any way to correct the model? I mean, retrain is like providing more data so that it understands the complex data etc.
So is there any way to correct it? You need to correct the source data. So it's predicting based on your source data. It's reading your source data and based on whatever is there in your source data, it's predicting based on that. So if you detect any anomalies, like if you have one peak thing, someone has entered 2 extra zeros in your sales figures, right? So that is something that you need to fix your data. So that's where you go back. And then
My question is something like existing coefficients sort of things. Then a way to correct it
we can't change that.
to come closer. Like when you train the data, if you compare with the actual data, and there may be some like if it's a value expect is a 4.2, but actual value is 4. Is there any way to correct those to predict it to closer values?
Right. So it will never be 100% accurate, as I've said before, but it depends on distribution of your data. So because your data is distributed more towards right, your predicted value is slightly going right than the actual value, right? So it's a distribution of your data. You will get closer to accuracy as you get more data, and equally like distribution is linear. So that's where I was showing the linear distribution here in R previously. So if you have linear distribution, then it will be, the predictions will be closer to accuracy. But you can't change the coefficient because that is the whole point, right? I mean, it is actually analyzing the data and coming up with a value based on your input data. And then if you can go and change it, there's no point in doing that.
Actually, my question is more of like most of the scientific experiments, they will be like error correction codes sort of things to adjust the figures. So is there a way to adjust the coefficient factor so that it comes closer?
I haven't come across any such thing, but as I said, I am also not 100% across this. So there may be some other models, or that's where maybe you will start writing your own algorithm. Probably use the existing one and then tweaking it a bit, probably. Yeah. But there are few open source projects, open source code that is available. And actually, I'll just get to the last slide, and then there are some references where you can actually go and see some of the projects that are already there. So we have seen that Azure ML Studio, right? So this is the slide I was talking about, where depending on what you want to achieve, what kind of algorithm you need to use, right? So most of the predicting values, you use regression algorithms, but if you are doing, finding unusual data points, like detecting anomalies, for the anomaly detection, use different algorithms here. So this sheet is officially published by Microsoft. So there is a link at the bottom. It's not clickable, but you can copy it. You can type it in. It's basically ML cheat sheet. So if you search for ML cheat sheet, you'll get this. So this has all the algorithms that you have in Azure ML Studio. Right, and don't worry, these slides will be uploaded, so you will get access to everything. And I have put in a few links, and Git repository. about all the projects. You can actually go and do it yourself. There are a lot of projects available here on Azure ML and data science. Right. So this is the official Microsoft Git repository where you have all the most of the training material that's available.
So what it includes, like R packages?
It has some samples.
Solutions.
It has some samples. It has some exercises that you can go through. It has some training videos, I think, and some hands-on labs that you guys can do. Right. And Azure ML Workbench is like on-premise data science implementation of Azure ML Studio. So that is more advanced and next steps of learning or actually implementing Azure ML Studio, machine learning in your organization probably. And there on Azure portal, actually you can directly create a data science VM. So you can, as you would do with SQL Server VMs on Azure portal, you can actually create a data science VM which has got all the components that you would need for doing a data science project. Like it has got the RStudio and all the packages installed, all the software that you need. That is all installed on data science VM. So it comes with pre-installed software that is required for your machine learning projects. Right? And again, if you have any questions, I'm available here for at least another 6 minutes. Yeah, and there's some raffles thing also. And if you have any questions, I'm available here, and you can scan the QR code and leave the feedback. Any places that I can improve and something that maybe I can add. Yep, I try to cover the basics, introduce you to RStudio, introduce you to Azure ML Studio, and show you a glimpse of using R inside SQL Server. So this is first steps towards learning, towards being a data scientist. Thank you, everyone.
And everyone's filled in the evaluation forms, I hope.